I'm Goldberg.
And welcome to Sports Center.
Today we're going to be talking about Rube Goldberg.
On today's episode, the first segment is going to be the steps. And to start it all off, is going to be a candle being lit that burns a string.
This is so exciting. Then a big marble falls on top of a lever.
After it falls on top of the lever, the opposite side rises.
And the opposite end hits a cardboard.
After hitting the cardboard, the Jenga blocks start to fall.
And then the Jenga blocks go up a ramp and knock down a marble.
I'm loving it. After the marble goes down the ramp, it goes into a funnel.
Then the marble hits a fan piece and falls into the cup in a pulley.
The cup goes down and it weights up a ramp.
The ramp attached to the other end of the pulley is lifted, inclined, and then drops a Jenga block.
The Jenga block hits the other Jenga blocks.
Ultimately, it ends dropping a cup of water.
Okay, everybody. Now, some text is going to appear on your screens, but don't be afraid. It's going to be explaining all the different types of physics that happened during this experiment. Thank you very much. We'll be right back. First is energy transfer. When the fire is lit to burn the candle, it is thermal energy to gravitational potential energy. Then, the second one, when the big marble is dropped to the lever, there is an energy transfer from gravitational potential energy to kinetic energy when it hits the lever.
Following up, we have mechanical advantage. In our pulley, the force exerted is in a push and a pull on two different objects, and it would be measured in newtons. The input effort is the basket, the half-cut cup full of marbles, which pushes the basket downward. The output, resistance, is the ramp with the Jenga block, which is the one being pulled.
The principle of conservation of angular momentum.
Next is momentum. Here we had two. After the marble goes into the funnel and into the toy ramp, the ball's velocity increases and therefore its momentum increases as well. Secondly, when the Jenga block hits the marble, the collision momentum is transferred or redistributed and not lost.
Following that is work. When the marble falls into the basket, there is a downward force applied onto the basket, therefore pushing it downward until it touches the ground, causing the opposite toy ramp to be pulled upward.
Next, we have power. Work in this experiment is done almost at the same time, but the basket works a little bit faster than the toy ramp, as it pushes down faster than the ramp pulls up, due to the extra mass. Therefore, it is safe to say that the basket holding the marbles has more power than the ramp.
And we're going to close it up with friction. There is static friction present in the positioning of the marble when placing it on the ramp. It had to be placed in a certain way in order for it to not move, to stay in position. This is important because we had to make sure that the marble stayed in the exact location in order for it to move forward and fall into the funnel. Also, there is kinetic friction in the funnel ramp, as the marble is in motion upon arriving at it. This is important because if it did not move or move as fast, there probably would not be enough force for the basket to pull up on the ramp and the pulley.
That was all for tonight, folks.
I hope you enjoyed the show.
Good night, everybody.
Good night. God bless America.
Hi, everybody. We got great news for you.
We managed to get a hold of the kids and interview them. These are the same kids that did that Rube Goldberg.
Could we ask you a question?
Why did you do this Rube Goldberg?
The grade?
The grade.
Counterpart of the lever hits a cardboard piece. I'm Rube Goldberg.
And I'm Goldberg.
I'm Goldberg.